So this is the topic dielectrics. Dielectrics are nothing but they will act like insulators only. Okay. Just like how insulators will behave, dielectrics are also same. Where we can observe the dielectric means you can see a capacitor. A capacitor will have some positive plate and negative plate separated by a dielectric. Suppose if you take a capacitor, you will have a positive plate and a negative plate, and in between you will be having a separation. That separating medium is called as dielectric, which will act just like insulator only. Okay, as insulator is having no free electrons, similarly dielectric materials will also do not have any free electrons. So dielectrics are just like insulators only. Your wood, rubber, all these will act as dielectrics only. Paper. So here in capacitors you can observe paper capacitor, mica capacitor, like that. Based on the dielectric medium that you are using, we can name some capacitors also. Okay. So just like insulators, dielectric also will not allow the flow of current through it. They will not have free electrons. Dielectrics do not have free electrons. Dielectrics do not have free electrons, just like insulators. Okay? So just like insulators, dielectrics also do not have free electrons. They will have charges, but they are not free. They are not free to move. Those charges are held by some. Those charges are bounded. Those charges are bounded by some finite forces. Okay, that means your dielectric material which will act like insulator, that means it will not allow the flow of current. They will not have free electrons to move. They will have charges inside them, but they are held tightly. They are bounded by some finite forces. Some forces will keep them in a stiff position. They can't move freely. Okay, so they are also called as bounded charges. Okay. So in dielectrics, the charges are kept tightly without any free movement by some finite forces. Hence, they are also called as bounded charges. Okay. Now, these bounded charges cannot move freely, so there is no conduction process. No conduction. Current conduction is not possible in normal case for a dielectric. But in dielectric also charges can move, but under the application of an external electric field. Okay, under the application of external electric field, the bounded charges shift their relative positions. Under the application of external electric field E bar. In normal cases, there will not be any conduction process. Those bounded charges will not move and there is no conduction process. But separately and externally, if you are applying some electric field, E bar to that dielectric, then those bounded charges will gain some energy and they will start shifting from their original positions. They will also shift from their relative positions. Okay. So when the charges are shifting from their positions, automatically conduction process will start in dielectric also. That is possible only under the application of electric field intensity E. Okay. So under the application of an external electric field E bar, those bounded charges will shift their relative positions against the finite forces. Actually, previously some finite forces are keeping them tightly in a fixed position. Now under the application of this electric field, they will shift from their relative positions against that force, then only they can move. If they oppose this force, then only they can move. Against the finite forces. Against the finite forces. Now, shifting of the positions, shifting of the positively and negatively charged particles, are in opposite directions. That is general. If you start the conduction process, means automatically if the protons are moving in this directions, the electrons will move in opposite direction. Just like in normal conductor, here also under the application of external electric field, the positive and negative charged particles will start shifting from their positions in opposite directions. Okay, in opposite directions. Such positive and negative charges will combine to form an electric dipole. Okay. Now, such positive. Okay. Now, under the application of this electric field, positive and negative charged particles will move in opposite directions. Such positive and negative charges will form small electric dipoles. Okay. So in dielectric also, though they are not having free electrons, though they will not conduct electricity, under the application of external electric field intensity E bar, they will oppose that finite forces and they will also gain some energy. And what will happen? They will shift from their relative position. The charges will shift from their relative positions and the positive and negative charged particles will move in opposite directions. Okay. So while moving like that, the set of those positive and negative charges will form small electric dipoles. Already we have defined what is meant by electric dipole in our first year. What is electric dipole? When two charges of same magnitude but opposite polarity are separated by some distance d, then such combination is called as electric dipole. Okay. So during this process, we can observe the formation of small electric dipoles in a dielectric. That process is called as polarization. Okay.